Okay, folks, I'm going to do this one in order. This is S.2 from IXL Algebra 1. This is the linear functions section, and I've been looking forward to this one. Unfortunately, this particular section tends to sneak up on you, and it gets really tough really fast. So I'm going to try and make it as simple as I can. I haven't previewed it, so I do remember from last year people had a lot of trouble with this one. So I'm going to try and make it as easy as I can for you. So here's a table, and we want to know, is this linear or nonlinear? And the best way to tell is if it is a constant slope. So what we're going to do is we're going to look and see if the difference in the y's, which happens to be, it happened to have gone up 2, and the x's went up 1. So we have a slope of 2, and the y's went up 2 when the x's went up 1. And so, yes, this is linear. Both sets of points have the same slope. And that's one way to do this. I'll see if when I get other problems, maybe there'll be a different way to do this. This one from 18 to 11 is 7, and this one went up 1. This one went down 7, and this one went up. So this is a non-linear situation. Now this one went up 14, and this one went up 4. So that's a slope of 7 over 2. This one went up 14, and this one, unfortunately, it also went up 4. So this one is linear. They both have a slope of 7 over 2. So from 6 to 8, it went up 2. And from 2 to 3, it went up 1. So that's a rise over run, or a change in y of 2 over a change in x of 1. So that's a slope of 2 over 1. This one went up 6, and this one only went up 1. So of course it's nonlinear because the second pair had a slope of 6, so that's nonlinear. This one has a change of 9. It went up 9, and this one went up 1. So the first 2 points between them have a slope of 9. The change in y over the change in x is 9. Now in the next pair, we went up 9, and we went up 1. So there's the same change and the same slope, so it's linear. This one, our y's went down 9, and our x's went up 1. So this is a negative 9 slope. This one went down 9, and this one went up 1. So this slope is negative 9 over 1 for both sets of points. And since the slope between the first and second is the same as between the second and the third points, they are linear. The change this time was positive 6. 3 to 9 went up 6, and the 8 to 14 goes up 6. So that's a slope of 1. Now the 9 to 18 went up 9, and the 14 to the 20 only went up 6. So this is non-linear. The second pair have a larger slope. So the negative 4 to 10 is a positive 14 change, and negative 8 to 6 is also a positive 14 change. So the slope between the first pair of points is 14 over 14, or 1. Now the slope between the second pair of points is 2 over 2, which happens to also be equal to 1, and so they are linear. Okay, now it's going to get a little more hectic here. All right, so the difference between these from here to here, we're actually going to subtract these, which happens to be 16. And the difference between these two is positive 4. So going from 9 1/5 down to negative 6 4/5, we actually went down 16. And from negative 8 to negative 4, we actually went up 4. So this is a negative 4 slope. That's the change. And from negative 6 4/5 to get to negative 10, we went down 3 1/5. And to get from negative 4 to 0, we went up 4. So clearly these are not equal, nonlinear. From 4 to 2 2/5. If you need a calculator, you can do it. You might want to think of this as 2.4, and the difference is we went down 1.6. I'm going to go ahead and say I went down 1 3/5. From 1/3 to 3, I went up 2/5. Sorry, 2/3. No, I did not. I went up 2 2/3. Sorry, 2 2/3. There we go. From 2 2/5 to 2/5, I went down 2. And from 3 to 8 1/3, I went up quite a bit. Boy, it looks like they could be linear. I'm going to see if there's a way to tell easily. Doesn't look like it. God, I can't think of any other way to do this. So I'm going to go with negative 1 3/5 of all things over, I believe it was 2 2/3. It's hard to see. Wow. By the way, this is about as ugly a fraction as I've ever seen. So what I'm going to do is I'm going to multiply the numerator and the denominator by 15. Let me show you what I'm going to do. Well, first I'm going to change them. You know what? I'm going to go ahead and change them to fractions. This is going to be negative 8 over 5 divided by, this one is going to be 8 over 3, isn't it? And that's negative 8 over 5 multiplied by 3 over 8. And the 8 cancels, and this stays negative 1, and I'm going to get negative 3/5. So the slope on the first pair is negative 3/5. On my second pair, I had a change of negative 2 over, and it looks like I went from 3 to 8 1/3, which is up 4 2/3. And that is negative 2 over 1 divided by, that's 14 over 3. And that is negative 2 over 1 times 3 over 14, which is negative 6 over 14. This is pretty darn close to that, but they're not equal, so it's nonlinear. Man, like I said, it sneaks up on you like a tiger, and then when it catches you, you're really sorry. Let's see, this one might not be so bad. It looks like I went up 1 1/3, or rather I went up 4/3. From this one to this one, I went up 1/2. So this one's not so bad. It's 4/3 over 1/2, or divided by 1/2, which happens to be 8/3. So my slope on my first pair is 8 over 3. Let's see what my second pair gives me. To go from 8 2/3 to 10 is 1 1. I went up 1 1/3. And to go from 9 to 9 1/2, I went up 1/2. So they are the same. That is, makes them linear. I'm trying to think of an easier way to do this. Oh, this is interesting. Okay, from negative 10 to 7 1/3, I made a change of negative 17 1/3. And to go from negative 10 to 7 1/3, I make a change of negative 17 1/3. So, sorry, positive. I went up 17 1/3. So to go from 7 1/3 to 10, I go up 2 2/3. And to go from 7 1/3 to 10, I go up 2 2/3. And it just so happens that the slope is equal to 1. By the way, the equation for this is y equals x. It looks like this if you were to graph it. When the x's and the y's are equal, they're on that line, which of course is linear. It's like the parent function of all linear functions. So this one is linear of all linears. Let's see what else we get. Okay, from 2 to 6, we went up 4. And from 1/2 to 2 1/2, we went up 2. So this slope is 2 between this first pair. To go from 6 to 10, we went up 4. And to go from 2 1/2 to 4 1/2, we go up 2. So they are the same, they're linear. From 19 to 12, I went down 7. And from 9 to 13, I went up 4. So this first pair of points have a slope for my first pair of -7/4. Let's see what happens in the next set. I went down 8, didn't I? From 12 to 4, I went down 8. And from 13 to 17, I went up 4. So this is -8/4, which is not equal. They're nonlinear, but they're darn close. If you were to graph those, it would look pretty linear. All right, from 1 to 10, I went up 9. And from 7 to 10, I went up 3. So this has a slope of 3. The change in y over the change in x, this is a +3, is equal to 3. So my slope in my first pair is 3. My second pair, I went up 9, and I went up 3. And of course, it's the same, so they're linear. Like I said, some of these can be a little bit challenging. From 0 to 5, I went up 5. And from 2 1/2 to 5, I went up 2 1/2. So 5 over 2 1/2. I took the change in y over the change in x, which is equal to 2. To go from 5 to 10, I went up 5, and I went up 2 1/2 again, and of course it's linear. 9 1/2 to 0. Oh my goodness, I went down 9.5. I'm gonna use decimals, what the heck. Oh no, I'm not. I don't like decimals when I have thirds. Hopefully you know why. That's gonna be 9 1/2, isn't it? There we go. I went down 9 1/2, and from -3 1/3 up to 3, I went up +6 1/3 spaces, 6 1/3. So this is -9 1/2 over +6 1/3. And I'm not going to divide it because look at what happened here. I went down 9 1/2. So as long as I go up 6 1/3, which I did, then it's going to be linear. Wow, from -10 to -1/2, I went up 9 1/2 units. From -7 2/5 up to 4, I went up 11 2/5. I can't write the 11 2/5 over there, so I'm going to write it over here. This is the slope, if you like. The change in y, because I went up, over the change in x, and I went up. Now I could turn these into fractions, do the division, yada, 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 and get the slope as a fraction. It's about 9 over 11, which is pretty close to 1. It's actually 9 1/2 over 11 2/5. So it's a little less than 1, not much. Now, I went up 10 1/2, didn't I? Because I went up the -1/2 to 0, and then I went up 10 more. So I went up 10 1/2. That's different than that one. In this one, I went up 4 1/5. Oh man, do I have to check this? Well, not really, because I can estimate it. Look, I know this is not equal to up 10 1/2 over +4 1/5. These are not equal, so it's nonlinear. I don't have to test it because I can see already that 10 and a half divided by 4 is nowhere near 1. So I went from 10 to negative 5, which meant I went down 15. And from negative 10 to 8, I went up 18. So my slope is negative 15, the change in y, over the change in x. And that reduces to negative 5 over 6. Now, from here to here, from negative 5 to negative 9, I went up 4. And from 8 to 9 and 3/5, I went up 1 and 3/5. So I went up 4 over 1 and 3/5. These one's negative and one's positive. They're not anywhere near equal. And looks like we have one last one. From 1 to 7, I went up 6. From 1 1/4 to 3 1/2. Hopefully everybody can see I went up 2 1/4. So this is positive 6 over 2 1/4. I'm going to see if I can think of a better way to do this and later and maybe include it with another video or something. But from 7 to 9, I went up 2. And from 3 1/2 to 8, I went up 4 1/2. So I have 2 over 4 1/2. And it's very obvious that these are not equal because a large number over 2 1/4 is something, approaching 2 and a little more. And this one is like a half. So this one's approximately 2, and this side over here is approximately a half. It's nonlinear. So it looks like I'm done. I'm using rates of change or the slope or the changes in y's over the change in x. Anyway, that's a nonlinear. And it looks like we're all done. Hopefully we can find a better way to do this. And when I do, I'll come back and show it to you. So good luck, guys. Hope you can get this done yourself. And I'll see you back again. Bye.